Hi everybody, myself Halawat Ramesh. Today we will talk about the atomic structure, especially in atomic structure, Schrodinger wave equation, Planck's quantum theory, Bohr atomic models. And you can see what is atomic structure and what are the main topics, especially in atomic structure, we will discuss today slide by slide. You can see here the picture itself, you can understand what is proton, neutron, electron. Those we will discuss in slide by slide. You can see the first one slide, the atomic structure. Simply you can see the atomic structure is the structure of an atom that is one positively charged nucleus with negatively charged electrons circulating. It called atomic structure. That is a simple definition. Atomic structure means nothing but is the structure of an atom that is in one positive charge nucleus and another one with the negative charge of electron. It's circulating, that is called atomic structure. So especially in atomic structure, I was mentioned here the 10 important topics. You can see the first one, Bohr atomic model, second one, Planck's quantum theory, third one, black body radiation, fourth one, shapes of orbitals, fifth one, Dalton law, sixth one, Brownian motion, seventh one, Schrodinger model, eighth one, isotopes, ninth one, valency, 10th one, ionization energy. You can see the first one, Bohr atomic model, or simply you can see the sum of the introduction about the atomic structure. According to the Dalton theory, the smallest particles of matter is atom, which is indivisible. The fundamental particles of atoms are electrons, protons and neutrons. This is the three main things, especially in the fundamental of particles. Protons and neutrons are called nucleons because they present in the nucleus. The atomic number Z means the number of protons present in the nucleus. Then mass number is equal, it is the sum of the number of protons and the number of neutrons present in the nucleus. You can see simply the mass is equal, A is equal Z plus N, or N is equal A minus Z. N is the number of neutrons. You can see this picture, you can easily understand. Here is that electrons are the negatively charged particles and the neutrons are the particles with a contain no charge, especially neutrons, and protons are positively charged, and this is called as the center of the part, that is called nucleus. Simply you can see the sum of zoom part, the structure of atom. You can see main parts here. Electrons moves around the nucleus, that path is called electron orbit. Okay, the center one part is called nucleus. Nucleus itself we have the protons and neutrons. Protons having the positive charge and neutrons there is no charge. And you can see these are the electrons rotating into the path that is called orbit. This is the structure of atom. You can see the first one, especially Bohr atomic model. What is the Bohr atomic model concept? The electrons moves around the nucleus in a circular path. It is called orbit or shell, which is the designed by the like 1, 2, 3, or you can see K, L, M, N. You can see as the electron revolves in the particular orbit, its energy is constant. So therefore this orbit is called stationary orbit or stationary cell. So this is very important. We can see here the picture of this Bohr model in 1921 after the Sommerfeld explained the 1913 model showing the maximum electron per cell with the cell labeled with X-ray notation. This is that model of the Bohr atomic. You can see that every orbit they give the numbering like letters K, L, M and simple another one is this is a nucleus part. You can see that here N is equal to 1, N is equal to 2, N is equal to 3, and when the electrons will jump from lower to higher, like one orbit to another one, what delta E is equal to hc, energy will be emitted. You can see here few of the sentence, with increasing the volume of the both energy, the size of the orbit also will increase. The Bohr model of atom was proposed by Niels Bohr in 1915. It came into the existence with the modification of Rutherford model of atom. This point is very important. So Rutherford model is introduced the nuclear model of atom, which is explained by the nucleus positively charged is surrounded by the negatively charged of electrons. So here you can see the one formula L is equal to n by h by 2 phi. L is the angular momentum, n is the principal quantum number, and h is the Planck's constant, pi is the this one. You can see now what is the limitation of Bohr atomic model. So it is not fulfill about the complete information about the atomic structure. So what is that demerits or the limitation of Bohr atomic model? It is applicable to only one electron systems only, but it failed to explain the fine spectra like splitting of spectral lines in the presence of electric field. Splitting of electric field, that is called Stokes effect. So Stokes effect, it is not explained by the Bohr model, and in the presence of magnetic field, Zeeman effect are not explained from the Bohr atomic model, and these theories not in the coordination with the Heisenberg uncertainty principle. This theory also is not followed by the Heisenberg uncertainty principle. These are the main points to the limitation. Next you can see here Planck's quantum theory. So Planck is considered as the father of the quantum theory. So according to this theory, energy is emitted or absorption takes place discontinuously in the form of pocket, or each pocket energy is called quantum. So energy is associated with quantum is proportional to the frequency of radiation. V is equal to h mu hc by 5. Here is h is the Planck's constant 6.63 into 10 to the power minus 34 joules per second. V is the energy of proton quantum. V is the frequency emitted radiation. So Planck successfully explained about the phenomena of black body radiation and photoelectric effect. Okay, and you can see the what is the black body radiation. So that is also very important. The black body radiation is the thermal electromagnetic radiation within or the surrounding the body of thermodynamic equilibrium, which is the environment. So emitted by the black body means nothing but an idealized opaque or non-reflective body. Is an body which is the perfect absorb or perfect emit of the radiation is called black body. So radiation emitted by such body is called black body radiation. Simply means in the black body or black body is an idealized physical body that absorbs all the incident electromagnetic radiation regardless of frequency or the angle of incidence. So the name black body is given because it absorbs all colors of the light. Simply means when the matter is heated, it emits radiation. So black body is a cavity in the material that only emits thermal radiation. Incoming radiation is absorbed in the cavity. That point is very important, especially in black body radiation. You can see now shapes of orbital. Atomic orbitals are fundamentally functions as describes wave numbers of the electrons or electron pairs of the atom. There are the four basic types of orbital: s orbital, p orbital, d orbital, and f orbital. You can see the points of remember. The orbits and orbital are the different concept. The orbit in the cells already we discussed in previous the first slide. Orbit is the well defined the circular path in the atom which the electrons moves around the nucleus, whereas orbitals are the three-dimensional space around the nucleus atom, which is the probability of finding the electrons in the highest. So difference between the shell and orbital, that is also very important. Shell is and the atom is the set of subcells of the same quantum number theory. So if orbitals consist of 2 electrons each, so orbitals consist of 2 electrons each, but shell is that is set of the subcells to the same quantum number theory. Next one you can see here, you can see the s orbital, p orbital, d orbital, and f orbital structures and their representation. And s orbital you can see, and p orbital and d orbital. Okay, dumbbell, and these things. And you can see especially f orbitals have the 3 nodal planes and complex shapes with the atomic nucleus at the center. You can see the representation of different type of F orbitals. Next one topic you can see here, Dalton's law, law of partial pressure. Dalton's law means nothing but of the law of partial pressure. So Dalton's law of particles pressures is gas law, which states that the total pressure exerted by the mixture of gases is equal to the sum of the partial pressure exerted by each individual gas in the mixture. For example, the total pressure is exerted by a mixture of two gases A and B equal to the sum of the individual partial pressure exerted by gas A and B, as the illustrated below. So Dalton law is related to the ideal gas, like PV is equal to N naught. Dalton law states that in the mixture of non-reacting gases P1, P2, P total is equal to P1 and P2. Continue the gases. Okay, and you can see the next one topic is Brownian motion. Nothing but the erratic random movement of microscopic particles in a fluid as a result of continued bombardment of from molecules, that is the surrounding medium. Means Brownian movement means in the chemistry you can say the random zigzag motion of the particles in the usually observed in the high power of the ultra microscope. There is no sequence. The particles will move itself in the fluid. There is a zigzag system. So this movement resembles the exact motion of pollen grains in the water explained by the Robert Brown. So hence the name Brownian movement. So how the name is came means the pollen grains is as a botanist he explained the Brownian motion. Brownian movement can be seen as a colloidal solutions. For example, you can see pollen grains is in a oil drop movement, plasma particles in the cells. These are the few examples of Brownian motions. Next one is the Schrodinger model. These are the very important in order to explain the behavior of electrons and other microscopic particles. A new branch of science that is called quantum mechanics was developed, that is Schrodinger. So quantum mechanical model was developed independently in 1926 by Werner Heisenberg and Erwin Schrodinger. So 1926 the Schrodinger discovered one of the fundamental of quantum mechanics, the famous Schrodinger equation known as the Schrodinger equation. So he used the differential equation to describe how the quantum states of a physical system change over the time. You can see that how the physical change are changing, move from one stage to another state depending on over the time. He explained that. You can see here the kinetic energy part and potential energy part and its total energy. This is the Schrodinger equation. You can see here dou square psi by dou x square plus dou square psi by dou z square plus dou square psi by dou z square plus 8 phi square m by h square v minus e psi is equal to 0. This is a Schrodinger derivative respective with z and the position. You can see Schrodinger wave functions and energy and potential. Next one you can see here what is isotopes. Simply see isotopes are the members of a family of an element that all have the same number of protons but different number of neutrons. You can see here the hydrogen is the best example. Hydrogen have a three kinds of isotopes. So here you can see here all are the same number of protons but different number of neutrons. You can see here there are the naturally occurring isotopes of hydrogen: protium, deuterium, tritium. These are the three forms of hydrogen isotopes. Okay, and next we can talk about the what is valency. Simply you can see what is valency. Valency is the probability of electrons or atoms combined to form a molecules. The molecules valency are when two atoms hydrogen combine and it is the one atoms or the oxygen to form a molecule. Simply you can say valency. What is valency? The valency electrons are outer shell electrons or atoms that can form a chemical bond with another atoms. Valency electrons, filling of electrons. This is the nucleus center of the bond. You can see the another one topic is ionization. Ionization energy is the maximum energy required to remove the most loosely bounded of electrons isolated gas state from positive or negative. first ionization energy representative this one. Okay,